Alright, so there, for physics, we start looking at a simple pendulum. It's just more like I'm taking you back a bit. You did this topic in grade 10, you people that studied with us. It's just more like I'm just trying to explain, because there's some exam questions that comes under a simple pendulum. I wanted to give you a question, but now others were not there. So we decided to say, okay, let us just have like a simple pendulum like that. So a simple pendulum is a small, heavy bulb suspended by a light and extendable string. Now, this means that, does it mean that a simple pendulum has got 3 bulbs there? No. To show that means that this one is able to swing from what? A to what? To C, and then come back to what? To A. But this is the original, but these are the what? The swing. Then you can swing like that. Maybe let me make it come on. Maybe mkaona. Okay, now listen. Yeah. So this is an example of a simple pendulum. So this is what we're talking about, the length of the what pendulum. Then support then what is happening is that for this is swinging from A to C and then back to what? To A. So I'll put it at one side, then Japan. So this is what? 1. So when it goes from A to C and back to A, it makes a complete circle, 1 circle. Yeah, so when you put it from here, then I release it. 1, then 2, then 3, then 4, then 5. So now, factors that affect the period of the pendulum. One of the factors is what? Length of the what? Pendulum. Now look at this. You should notice what is happening here. Chakula ichi, maona mwechi chiswingi ndivyo. Nikafupi hisi. So what is happening there? What do you think the time is faster? Is it when it is longer or when it is shorter? Shorter. You say shorter things are better than long things. So, when the bulb is put to the side and then let go, the gravitational force of the earth causes it to swing back and what? Forth. Back and forth. When it is put from one end and then it is released, then it is able to swing back and what? Forth, like that. So swinging. But this is the length of the pendulum light string. So light. Then this is what? The bulb. So whether it means that the time it will take, as long as liquid is so let's say this is the length. So the time it is taken, so when the stopwatch the one so the moment I release, now start. Come on, practical. Yes, so you start the time. The moment I just release back almost I am time. So it means that then stop. The time it is taken to swing from A to B is that, so that will be the period of the pendulum. Now, if I was to change up and I chose up the time it will take is still more, it will be what? The same. So the bulb, the mass of the bulb does not affect the period of the what? Pendulum, but the period of the pendulum is affected by the what? The length of the what? The string. Are we okay there? Yes. Very good. Now so we're saying that the period of, so an oscillation, question come up with that define an oscillation. Wait, don't worry, because I wanna my exercise. Come up with a question that define an what? Oscillation, or what is an oscillation? Can you check? Say an oscillation is a complete to and fro movement of the bulb. It is also called the what? A circle or vibration. The to and fro, just like that. To and fro, yes. Not to and fro. Furo. From. To and fro. It is also called a circle, a vibration, or a swing. So you can say an oscillation is a complete to and fro. To and fro means this one is a circle, mean that it's a to and what? Fro. To and fro, to and fro. Just like making what? A circle. Now, now, When the bob is swinging from A to B, what is this? Is it half full? Put it half? Half. Quarter, which is put it so. Put it, how many are they all together? But for it to make one complete oscillation, how many are they all together? 4. Guys, they say 1, 2, then what? 3, then what? 4. So the total number of swings, how many are they? 4. Imagine from A to B, what is that? It's what? 1/4. It's 1 out of what? 4. The total for one oscillation is what? 4. So it means that A to B is what? 1 out of what? 4. So A to B is 1 out of what? 4. What about B to C? Again, now upper B to C is what? 2 over what? 4. Manche 2 over 4 is what? Half. That means that A to C is what? Half. What you understand? A to what? To C is kind 1, 2. So it means 2 over what? 4, which gives us what? Half. Now what about C to B? It's what? 3 out of what? 4. And B to A is 4 out of what? 4, which is what? 1. Means that one complete what? Oscillation. So A to C back to B is 3 over what? 4. But A to C and back to A is what? 1. Dear one oscillation. So it's A upper nishane half. Again half is what? 1. So this is what? Quarter. 2 quarters, which is what? Half. 3 quarters and what? 4 out of 4, which is what? 1 complete oscillation. Very important, because that one is going to affect you by exercise. Then think about the period. This is the time taken to complete one cycle of the motion oscillation. It is measured in what? Seconds. And it is given by the formula T is equal to T over what? N. Or T is equal to 1 over what? F. Sometimes you cannot be given the time and the number of oscillation, but you can be given the what? The frequency. So after you are given the frequency, you can use this formula. Are you okay there? Yes. Frequency F, this is the number of oscillations completed per what? Per second. Or is the number of cycles in how many seconds? 1. It is measured in what? Hertz. So. And then it is given by the formula F is equal to what? N over what? T. Or F is equal to 1 over what? T. Now, let's look at the examples there. Need to go fast? No. Okay. Need it slow. Very good. Need it slow. Muzambela. Very good. Muzambela was also. That's Muzambela. But we explain again. A simple pendulum completes 50 oscillations in how many seconds? 60. Calculate the what? The period. So it means that number of oscillation. How many oscillations are there? 50. There are 50. In how many seconds did you complete 50? Is what? 60 what? Seconds. Then find the what? T, which is what? Period. What did I say about period? The formula is there. So T is equal to what? T over N. So T is equal to, what is our T there? 60. Divided by what? 50. Which is our T is equal to what? Can you divide the greater? 60 divided by 50. 1.2 seconds. So the time it will take to make one cycle is what? 1.2. But how many cycles were made there? 50. But how many? In 50, how many? 60. So each one of them was taking what? 1.2. 1.2. So there, how many cycles are there? 50. But one cycle was taking what? 1.2 seconds. Well, we're there. Frequency. Again, frequency is the same. We've got the data there. N is equal to what? 50. Then T is equal to what? 60. That means that F manje is equal to what? Question mark. We don't know. Mean that F is equal to what? N over T. Which means F is equal to, what is our N? Our N is what? 50. Divided by what? 60. Which means F is equal to what? 0.8. 0.8. 8. So 0.8 what? Yes, H is there. If you don't want, we already found the what? The period. So it's simple. F is equal to 1 over what? Period. Which means F is equal to 1 divided by what? 1.2. And what is 1 divided by 1.2? 0.8 what? Yes. Simple. Is the same. Pesa home. Formula, very simple. Just hii ni other formula. Since tezatapeza kudala hii, we can use the second formula which says that 1 over t. So tzakwenda chapa t. Frequency is equal to 1 over t. T represents what? The period. Which means 1 over. What is our period? Period is what? 1.2. When you divide 1 divided by 1.2, the answer is what? 0.8. It's the same answer, isn't it? So it's the same formula. It's either you can use the other one here, as long as you have this. But sometimes if you don't have this, that's when now you can use this formula here. We are good?
Yes.
Okay. Now, exercise manje karibu ino manje. The diagram shows a simple pendulum that oscillates between A and what? C. If it takes 2 seconds for a bob to swing from A to what? To C. A to C. And from A to C and back to B. How many seconds is it taking? 2 seconds. Now we're supposed to know how many oscillations are there from A to C and back to what? B. How many oscillations are there? Nezaka mapati. Hapa nchani 1 over 4. Hapa nchani 2 over 4, which is what? Half. Kukwenda ukishani 3 over 4. So it means that A to C and back to B is what? 3 over 4. What is 3 over 4? Number of what? Oscillation. So our N is what? 3 over 4. But we can express this in decimals. 4 into that 0 point, where the 0 there should be 75, right? Moment. Okay. Then after that we go to what? Time. How long is it taking to move from A to C and back to B? How many seconds? 2. So the seconds is 2 what? Seconds. Then we are looking for what? Period. So which is what is our T? We don't know. Which is T is equal to what? T over N. Which is T is equal to what is our T small letter? 2. Divided by what? 0.75. Which means T is equal to what? 2.6 Charlie seconds. So the time it will take to complete one oscillation, it will take what? 2.1 that. In our method, Janemunga 7 is much. In Yaukawala, Muzabara Mukabat, 3 over 4 is equivalent to what? 2. Tell Kama 3 over 4 anyway. 3 over 4 is 3 over 4 oscillation is equivalent to how many seconds? 2. What about what? We're looking for what? Period. Period is what number? 1. From A to C back to A, it's 1 complete oscillation. So what about 1? Is equal to what? Egg is C. We don't know the time it will take for 1. So now what is this as a decimal? It's 0.75 over 1. Is equal to what? 2 over what? X. Cross multiply. Which is 0.75 times X. Is equal to what? 2. Divided by what? 0.75. Divided by what? 0.75. Which means this one and this one out. X is equal to, if you can check, 2 over 0.75. 2 over 0.75. My one. So it means that the answer is what? 2.1. So that we have a formula to say, hey, in the formula, confusion in my boiler, but T is equal to T over N. Suppose is it T over N, or N over T? But I mean, frequency in N over T, period in T over N. Suppose we have it's okay, I'll just use the other one. 3 over 4, the number of oscillation is equal to, even here, we could have used the same. We could have said, 50 complete oscillation takes how many seconds? 60. What about what? 1 complete oscillation. Takes how many seconds? X. Then from there you cross multiply it. You would have gotten 50x is equal to what? 60 times 1 is what? 60. Divided by what? 50. Now, 50 means that 60 divided by 50. Why is 60 divided by 50? Yeah, 60 over what? 50. Now, but 60 over what? 50. And the x here represents the what? The period for what? For 1. So what you get here is the same as here. That whatever you can still use that method today. There's no project. There's no program. I can put here. Then, for frequency, we use the simple formula. I already have the what? The T. So I'll just say FO is equal to 1 over T. So FO is equal to 1 over, what is our T? 2.6. FO is equal to, what is 1 divided by 2.6? Those with calculators. 0.380. What's it? Oh yeah, it's going. Okay, so 0.3 what? 8 what? Yes. Ngati wakabawe basaini panifuta. Okay, go back with the formula. F is equal to what? N over T. Do you know N? Yes. Our N is here, which is what? 0.75. What is the time there? 2. Which means F is equal to what? 0.38. Kaya, forget it. The moment 0.75 divided by 2. This is an answer. Is that an answer? So it's simple. Utuma question mama tuleta manini. Like I'm exercise. So exercise infuna ka full question. And sometimes they even ask you a question, say mention one factor that affects the period of what? Pendulum. Or what mention 2 factors, or maybe mention 1 factor that does not affect the period of the pendulum. What does not affect the period of the pendulum is what? The mass of the what? Ball. Whether chakara point chikuru, it means it cannot affect the period of the pendulum. The only thing that can affect it is the what? The string. That's why there's nakamba for but if we are to stopwatch so we start swinging. Apa pamene swinging apa. Muona tunaona chenda slow like this. Manje na kwenda kama ta ifuna kangono chwa mwagao na mwega inde aka kana chu. Oza kanisa binangu it's this one. You people you go very far. Come back here. Now wait. So exercise. If by example from way that we be idea pa equals we be idea. That's what mama to show na pa mandate so you have ideas. Sikuta I'm threatening you what? Is that come figure that? Is that one? Fine, I'm not threatening you. It's mandated.